Okay, let's knock out this practice test here on Unit 4 on quadratics. Remember, the instructions here say we can't use a graphing calculator. You won't be able to use a graphing calculator at all on the test. As long as you're not using the graphing capabilities on a calculator, then that's fine for practice and stuff like that. But just realize on the test you won't be able to use a graphing calculator. So let's follow the instructions here. It says find the zeros of each function by factoring. So they could have said find the solutions, find the roots, find the x-intercepts, anything like that would have been fine. So what we want to know is when does this function equal 0? Well, we're going to do this by factoring. So we're going to take out a 2x. So if I take a 2x, I'm left with an x and a minus 6. And we want to know when that stuff equals 0. So one or both of these factors have to be 0. So 2x is going to equal 0, or x minus 6 is going to equal 0. So if I divide by 2, I end up with an x equals 0, and I'm just going to write that off to the side here. And then I'm going to add 6 to both sides on this one. So we get x equals 6 for that one. So I'm just going to go ahead and circle the two of those and set those off to the side. That's the answer on that one. Then we're going to take a look at this one. We're going to factor here. So we're going to always take out the GCF. I can take a 3 out of each one of those. So if I take out a 3, I'm left with an x squared, a plus 10x, and then a minus 24. So what we're looking for here is two numbers that multiply to be negative 24 that combine to be positive 10. So if they multiply to be a negative, one of them's got to be negative, the other one's got to be positive. So if I run through my list of factors, I'm just going to write down 1 and 24, 2 and 12. Hey, that would, I can make a 10 out of a 2 and a 12. So here's what I think I need, and I'm going to double check this. Because they have to combine to be a positive, I think I need a negative 2 and a positive 12. So I'm going to get rid of this guy right here. Let's double check. Do they multiply to be negative 24? They do. Do they combine to be positive 10? They do. So here's what we've got. We've got factors of 3 out front. Don't forget that one. And then we've got a minus 2 here, and then an x plus 12 right here. Now, if you don't, it's not terribly important that we have the 3 there. We could take care of that a couple of different ways, because the 3 is never going to be what equals 0. So this is just not going to give us an answer. But the answer that I get from this one right here, if I said x minus 2 equal to 0, I get an x equals 2. And if I set x plus 12 equal to 0, I move that to the other side, and I'm going to end up with a negative 12. So there are the two answers to that one. Positive 2 and negative 12. Then I'm going to come down here and take a look at the next one. This one you'll notice only has 2 terms, so let's think about the rules that we learned there. There's no GCF to take out. If there's only 2 terms, the only tool we have to factor that right now is difference of squares. So let's see if this is a perfect square. It is, of 2x. That's a perfect square of 5. So here's what we get on this one. We get 2x minus 5, and we get 2x plus 5. So we want to know when this one equals 0, when 2x minus 5 is equal to 0, and we want to know when 2x plus 5 is equal to 0. Well, we're going to take this and we're going to move the 5 over to the other side. So we're going to add 5, and then we're going to end up dividing by 2. So I end up with one answer that's going to be, this is going to be a 5 over a 2. If I move the 5 to the other side, this is going to be a negative 5. Then I'm going to divide by 2. So I end up with a 5 halves and a negative 5 halves for the two answers on this one. All right, and then we'll take a look at this last one right here. Let's see what we've got. We've got 3 terms. This is a hard trinomial. I could multiply the two of these together and get 36 and then do it by trinomial grouping. But if I can save myself a little bit of time by looking at this and saying, hey, I noticed that this is a perfect square of 3x, and this is a perfect square of 2. And if I multiply those together, I get 6x. And if I double 6x, I get the right middle term. Now, the sign we'll take care of here in just a second. So this is a perfect trinomial square of 3x and 2. We'll square that quantity, and it keeps that sign of the middle one. So this is 3x minus 2 quantity squared. So I really only have to solve one of these. So this is going to be 3x minus 2 equals 0. Add 2 to both sides. Then we're going to divide by 3. So we get this. We get x equals 2/3. Now, sometimes people refer to this as a double solution or a double root, because this, it actually, we don't say it crosses there. If we were to look at what this function would look like, if it only has 1 0, we can imagine that this is, let's see, this is a parabola that opens up. It would actually come down and touch the x-axis. If this is 1, it would actually touch it right here, and then it would go back up. Okay, pretend that that touched right there. Okay, so that's how we solve for zeros by factoring. Let's take a look at the next one here. Same instructions, except for now we have to complete the square. So let me change over here. We want to complete the square on this one. So this is what we're going to do. We're going to set this equal to 0. And then we're going to move the 24 to the other side. So this is x squared plus 10x. I'm saving room to complete the square, so I move the 24 to the other side, so that's going to be a positive 24. I take half the middle coefficient. Half the middle coefficient is a 5. I like putting a plus 5 right there. It just reminds me because I'm going to use that again in just a second. And I square this and I put it right there. So this is going to be a plus 25 here, and it's going to be a plus 25 here. Now, the reason I put that in different colors is because I physically changed this. The x squared, the 10x, and the 24, those were all in the problem to begin with. Again, this changed sign because I moved it to the other side of the equation. But the 25 on both sides, I added those on both sides. So here's what I get. I get x plus 5 quantity squared. And over on this side, I get, let's see, 24 plus 25, that's going to be 49. And then I solve this by taking the square root of both sides. So this is going to be x plus 5 equals, don't forget the plus or minus. So one of the answers is 5 plus 7, and the other one is 5 minus 7. So this ends up giving me, let's see what I get here. I get an x equals, this would be a 12 out of this one and a negative 2 out of this one. Okay, so whoops, let me make that look right there. So a 12 and a negative 2. Okay, so there's the answer on that one. Let's take a look at this one. Again, we're going to set this equal to 0. And I'm going to blow this up just a little bit so I can attempt to make my writing look a little better. Let's see. So the first thing we're going to do is we're going to move the 3 to the other side. So we're going to have 3x squared plus 18x equals, and again, saving room to complete the square. So that's going to be a 3. I'm going to divide everything by 3. So this is going to give me an x squared, and then this is a plus 6x, and then on the other side I have a 1. And then I'm going to take half of this, which is a positive 3, so I'm going to put a circle around that. I'm going to square this, which is going to be a 9, so I'm going to add 9 to both sides. So here's what I get. I get an x plus 3 quantity squared equals, on this side I get a 10, and then I'm going to take the square root of both sides. So this gives me x plus 3 equals, again, put the plus or minus on there. So I get x equals, this is going to be a negative 3 when I move it to the other side, plus or minus radical 10. And it's just easier to kind of leave it like that. So there's our answer on that one. Okay, we're going to slide down and take a look at number 7. So on number 7, again, we're solving by completing the square. So I'll set that equal to 0, and I'm going to move the 5 to the other side. So this is going to be 4x squared minus 12x. Save room to complete the square, put the negative 5 on the other side. And then I need to get rid of this coefficient. So I need to divide everything by 4. So I'll divide everything here by 4, every term on both sides by 4. And here's what I get. I get x squared minus, let's see, that's a negative 3x. Save room to complete the square. That's a minus 5/4. All right. And then we're going to take half the middle coefficient. So half of this is negative 3/2. I'm going to keep track of that for just a second. And then I'm going to square this. And when I square a negative or a positive, I still get a positive. And fractions are easy to square because I just square the top and bottom separately. So this is going to be a 9 on the top and a 4 on the bottom. So if I add 9/4 over here, I better add 9/4 on the other side. So this is going to be 9/4 on that side. And I think there's some cool stuff that works out on this one. So this is a perfect square of x and minus 3/2 quantity squared. And over on the other side, cool, we've already got a common denominator. And I end up with, let's see, 9/4 minus 5/4. I'll just think of this backwards as 4/4. So that ends up being a 1. So we've got a 1 right here. So I'm going to take the square root. So I end up with x minus 3/2 equals plus or minus 1. So what I'll do is I'll write it this way. I'll write negative 3/2 plus 1 and negative 3/2 minus 1. So this would be, let's see, 2 over 2, 2 over 2. So we're going to end up with, that's going to be a negative 1/2. Yep, that's a negative 1/2. Oh, double check here. Yeah, that isn't, oh, I see what I did here. Got to move this over, okay? So this is going to be, whoops, I forgot about that. Let me back up, okay? So this is going to be a 3/2 plus or minus 1. So now let me write that, okay? So it's a positive 3/2, and then it's going to be plus 1, which we're going to think of as 2 over 2. So this is going to be 5/2. And this is 3/2 minus 2/2, so that's going to be a 1/2. So here are our two answers on this one. It's going to be 5/2 and 1/2. So we've got those two right there. All right, glad we caught that. Okay, let's take a look over on this one. Again, set this equal to 0. And then we're going to move that over to the other side. So this is going to be negative 9x squared minus 18x. And if you want to do a little bit of this work at the same time, that's totally okay. I'm just hitting all the steps. So we're going to divide everything by negative 9. Divide by negative 9 here. So let's see. This is going to give us an x squared. This is going to be a positive 2x. And then we're going to save room to complete the square, and that's going to be 4/9. Positive 4/9. And then I'm going to take half the middle coefficient. That's going to be a positive 1. And I'm going to square that. So I'm going to add 1 to both sides. And again, when I add 1, I'm going to think of that as like 9/9 here in just a second. So this is going to be x plus 1 quantity squared. And then over on this side, this is going to count as 9/9. So this is going to be 13/9. And then we take the square root. Okay, so let's see. That's going to give us x plus 1 equals, this will be the square root of 13 over the square root of 3, square root of 9, which is 3. And then don't forget the plus or minus. And then really with some ugliness like this, it's actually kind of cool because all I have to do is move the 1 to the other side. So that's going to be a negative 1. And then I'm going to have plus or minus radical 13 over 3. Now, we could clean this up and make this look a little bit better. We could write it as one single fraction. We could get a common denominator here. But I'm tempted to just leave it like that. The other thing that's kind of cool about that, if you're thinking about maybe as we're going to do next, putting these things in vertex form, there's some cool things that work out with that. So I'm going to slide down here and take a look at the instructions. It says write each one in vertex form by completing the square. So similar to what we did up above, with some tiny differences about how we compensate. Identify the direction of opening, the vertex. If the vertex is a max or min, state the equation of the axis of symmetry and graph the function. Okay, so let's go ahead and go for this. Vertex form, remember, looks like this. Y equals, or f of x equals a, x minus h, quantity squared plus k. And that gives us a whole bunch of good information about it. So here's what we're going to do. I'm going to save room to complete the square. By writing it like this. I'm going to bump this 11 way out on the end here, and I'm going to put parentheses around this. Now, if I don't have a leading coefficient of positive 1, I'd have to factor that out. I get lucky on this one. So I'm going to take half of this middle coefficient, which is a negative 3, and then I'm going to square that. So I add 9 here. And the trick on this one is I've got to know how I compensate for that. So there's a 1 outside here. So I'm going to draw a little line right here. And I always like doing this. This is a 1 out front. I added 9 inside the parentheses. If I multiply it by the 1 out front, I really did add 9 here. So I compensate on the same side by subtracting 9. So I add 9 here, truly is adding 9. So I compensate there by subtracting 9. And then this is what we end up with. We've got y, and then this is a perfect square of x and a minus 3 quantity squared. And then 11 minus 9 would be a positive 2. Looks pretty good. So once it's in this format and knowing that there's a 1 right there, I can tell everything I need about this. We take the opposite of the x coordinate. So that's going to be, let's see, or the number with the x. That's our minus h if you want to think of it that way. Opposite of h is what the x coordinate is going to be. So this is going to be 3 comma, whatever this k is. So this is going to be 3 comma 2. Oops, I need to put that in vertex form. I'll slide that over here, okay? So y equals, this is going to be x minus 3 quantity squared plus 2. It opens up because of that 1 that we were talking about just a second ago. The vertex is, now it's time for this one, opposite of that number right there, so 3, same as that number right there, 3 comma 2. And this one opens up, so it's going to be a min. So we can either circle that or just write the word min in there. And then the axis of symmetry, remember, is going to be the x coordinate of the vertex. So the axis of symmetry is going to be x equals 3. And then we want to make a nice graph. Now it does say graph, so we probably want to label a few things. So let's take a look at here. I'm going to zoom in just a tad on this one so it'll look a little bit better. This goes through 3 comma 2, so right there. And it hasn't been stretched or shrunk at all. So I'm going to go over 1 and up 1 squared, over 1 and up 2 squared, back 1 and up 1 squared, back 2 and up 2 squared. So it looks something like this. Okay, and if we were to label a couple of points, 3 would probably do it. 3 comma 2 is the vertex. This point right here, I'll actually point to that one. This point right here would be, if we go over 2 more, that's going to be 5. And if we go up 4 from 2, that's going to be 6. So 5 comma 6. This one right here is going to have the same y coordinate. So that's going to be 6 and 1. And if you wanted to label this one right here, this would be, let's see, back up 1 and up 1. So that's going to be 2 comma 3. Okay, and we could label a whole bunch of them if we want. When it says graph rather than sketch, we probably want to include a little bit of extra information. Okay, so let's take a look at the next one. Again, we're doing this by putting this in vertex form. So I'm going to write f of x over here, and then I'm going to, couple steps at once. I'm going to take out the negative 3. So that's going to be an x squared minus, remember it changes sign of that, so that's going to be a minus 3x. And then what I'm doing is I'm pushing this 1 out here because it's not going to be part of the perfect square. So everything here in red was part of the original problem. And now I'm going to go through and complete the square. So this is going to be half of this. So that's going to be negative 3/2. I'm going to keep that number because I'm going to use it again in just a second. And what I'm going to do is I'm going to square that. So I'm going to add 9/4 here. Now, this is where it's important to always come back and consider, what's that number out in front? Because what did I actually do on this side? So what we actually did is, if we multiply here, we actually subtracted, let's see if I thought of that as 3/1, I actually subtracted 27/4. So if I subtracted 27/4 from this side and I've got to compensate on that same side, I do the opposite of that. So I'm going to add 27/4 right here. Okay, so let's see what we've got. This is going to be f of x equals, and I guess I could slide over there and do it. It's a negative 3 in front there. And then this is going to be x minus 3/2 quantity squared. And then we'd add these together. This would be 4/4. Or you can throw it in your calculator, I suppose, if you want to. But this is going to be plus 31/4. Okay, so this is what it looks like. I'm going to write it over here in vertex form. So I'll write f of x equals, we've got the negative 3. We've got x minus 3/2. Okay, looking kind of ugly here. Let me let my computer catch up. Square that, and then plus 31/4. Okay, and then we're going to come over here and say, well, this opens down. And if it opens down, that means it's going to have a max. And the vertex is opposite of that number right there. So that's going to be 3/2 comma, same as that number right there, 31/4. 31/4, it might be important to note, is 7 and 3/4, I think is what we are. Okay. So let's come over here and take a look. And the axis of symmetry, always x equals the x coordinate of the vertex. So this is going to be 3/2, and I am going to need to get a little bit closer on this one. Okay, so let's take a look. And it opens down and it's been stretched by a factor of 3. So we want to make this look as nice as we can. So 3/2 and then a little bit less than, let's see, so 7 3/4. So about right there. Okay, so that point is 3/2 comma 31/4. And then if we were to go over 1, we would normally go down 1. So that would put us about right here. We're going to go down 3 times as far. So we're going to go down 1, 2, 3. So that would put us about right there. And then there's another one over there. Now, we could do a whole bunch of fancy stuff on this one, but we've labeled that. It would be cool if we could label some other ones. I'm not too terribly concerned about this one. If I were to label that point, it would be half a unit further than this one. So that's, 1 unit further than this one. So that's going to be 5/2. And we went down 3 from this one right here. So let's see if I went down 3, 31/4 minus 3, or that would be minus 12/4. So I think we'd get to 19/4. Now, that's a lot of work to do. So I think as long as we've got that, a decent graph of that and a decent sketch with a couple of points labeled, then I think we're in good shape. So we're going to flip the page over and take a look at the other side. So on the other side, it's the same type of thing, but you got to be careful with this one. This one has that nasty 1/2, and a lot of people struggle with factoring out fractions or decimals for that matter. Remember, what we're doing is we're dividing it out. So I've got a couple suggestions there. One thing you could do is you could literally just divide this by 1/2 and think, hey, I don't divide by 1/2, I flip it over and I multiply. One other thing that you can do is you can think of, hey, if I got a common denominator with this, and I'm leaving the 15 off there for the time being, right now it's a 1. So if I were to make that a 2, I'd have to make that a 12. So a couple different reasons why we're going to end up with a 12 here. So here's what we're going to do. I'm going to write down y equals, and I'm going to zoom in just a tad on this one. Slide over here. So this is going to be a 1/2, and then we've got x squared. If I divide this by 1/2, I flip that over and I multiply, or if I thought of that as the 12 halves and I took out the half, I'm left with a 12. Luckily, we don't have to cancel out or factor out a negative or anything like that. And again, the 15 is just going to get tucked over here on the end. So we only factor something out of the two variable terms. We leave the constant on the end. So these things, if you wanted to multiply through and double check, these are all parts of the original problem. We're going to take half that middle coefficient. So that's going to be a 6. I'm going to write a positive 6 right here. I'm going to square that. So we're going to add 36 here. But before I compensate over here, I have to consider the fact that out in front of this set of parentheses is a 1/2. So what I really did is I really only added 18 to this side. So I'm going to compensate by subtracting 18. So here's what I end up with. I end up with a y equals 1/2. And then I've got an x plus a 6, quantity squared, and then this is a -3. So it turns out on this one, it works out to be pretty nice. So this is going to be y equals, this is 1/2. I'll write this junk over here, plus 6, and then that's squared, and then -3. Let's see, it's positive, so it opens up. The vertex is opposite of the one with the x, so that's going to be -6, comma, same as that number right there, so -3. It opens up, so that's going to be a min, and then the axis of symmetry, always x equals the x coordinate. So that's going to be -6, and let's see what we've got here. So we're going to go back 6 and down 3, so we're going to be right here. There's the vertex, -6, comma, -3. And then because this has been shrunk by a factor of 1/2, we normally would go over 1 and up 1. We're going to go up half as far, so we're going to go about right there. Same thing on the other side. We would normally go over 2 and up 2 squared, so we're going to go up half as far as 4, so we're going to be about right there. So that is a decent picture of what this is going to look like. Okay, and again, if we were to label a couple of these, I'm going to zoom in just a little bit. So remember, we're going over 1 and we're only going up half as far. So if I go over 1, that's a piece of cake. That's going to put me at -5. And if I go up a half from -3, that's going to be -2.5, or I'm going to write -5 halves. And then I can do the same thing on the other side. So I'm just going to go the other direction. That would be -7, because I'm going to the left there, and I went up. It's going to have the same y coordinates, so that's going to be -5 halves, okay? So again, decent graph there. You don't have to label a whole bunch of stuff. Don't get too carried away, but it should look pretty nice. You should know a lot about the type of function and what the parabola looks like. Okay, so this one says, identify the vertex of each function and state whether the vertex is a max or a min. So we just need to identify the vertex. We don't need to graph it or anything. We just need to say whether or not we've got a max or a min. So on this one, we're going to use that little formula. And that formula was this: opposite of b divided by 2a. And then we take this and we plug it into the function. Okay. So once everything's determined by the x coordinate here, everything's driven by that. So here's what we're going to do. We're going to take this and we're going to do that. X coordinate is going to be the opposite of that one. So that's going to be -4 divided by 2 times 2. So that's going to be -4 over 4. So we end up with -1. So the x coordinate of the vertex is -1. In order to find what the y coordinate is, we're going to take this and we're going to plug it in. So we're going to find f of -1. So this is going to be 2 times -1 squared plus, 4. Come on, there we go. 4 times -1. And you'll notice that I'm plugging things in parentheses, and we got to be careful with this. Remember, we take care of exponents before we take care of multiplication. So you're not going to multiply the two of these together and then square it. You're going to square this one first. So remember, if you square -1, 2 negatives make a positive. So this is going to be a 2. This is going to be a -4. And this is going to be a +3. So this is +5. That's going to be a +1. Okay. So we get a +1 out of that. So +1 right here. So that means the vertex is at -1, comma, +1. There's the vertex. And we just need to say what it is. Because it opens up, it's going to be a min. Okay. So we're going to go ahead and circle that. And then we'll just keep going on this here. So on this one, again, formula right here, opposite of b over 2a. So the opposite of 12, -12. So minus a -12. And then over 2a. So that's going to be 2 times -12. This is going to be a +12 on the top and a -4 on the bottom. So this is going to be a -3. So here's our x value. put that off to the side right there. So -3 comma, we just need to figure out what this is. So we're going to do f of -3. So that's going to be -2, -3 squared, just plugging into the function right here, and minus 14. So let's check and see what we get. Okay, so if I square -3, I get a 9. And if I multiply that by -2, I get -18. This is going to be, let's see, negative times negative, that's going to be a positive. So that's going to be 36. And then minus 14. Okay, so if I put the two of these together, I get -32. And then if I add 36, this is going to be a positive 4, I think. Okay, so we get a 4 right there. So I'm going to go ahead and circle that. Oops, so we forgot one thing, max or a min. It opens down, so this is going to be a max. All right, so we'll go ahead and circle that and then take a look at this next one here. So on this one, gosh, got to be a little bit careful here because we're going to take the opposite of 3 and we're going to divide it by 2 times whatever a is. That's a -1/2. So this is a -3 on the top, and that is, well, those cancel, so that's a -1. So that means the x coordinate is a 3. So I'm just going to write the vertex over here has an x coordinate of 3. We'll figure out what the y coordinate is. So here's, if I plug this in, this would be -1/2, 3 squared plus 3 times 3 minus 6. So this is going to be -9/2 plus 9 minus 6. So these are going to cancel to be a 3. So I've got -9/2 plus 3. So this is going to be -9/2 plus 6/2. So this is going to be a -3/2. Now you could do this arithmetic on your calculator. You could plug it in. Again, not a graphing calculator, but you could have a calculator help you with that. This opens down, so this is going to be a max. Okay, so we'll go ahead and circle that one. And then one more of these to take a look at, getting lots of practice here. Opposite of b, that's going to be 24 over 2 times a. 2 times 3 is going to be a 6, so I get a 4. So that quickly I know the x coordinate of the vertex, and then I'm going to plug in a 4, so this is going to be 3 times 4 squared minus 24 times 4 plus 49. So this is going to be, let's see, 4 squared is 16 times 3 is going to be 48. Minus, that's going to be a 96, and then this is plus a 49. So I think if you take a look at that, these two actually add up to be 97 and minus 96. This is going to end up being a 1. So we have 4 comma 1 here, and this opens up, so this is going to be a min. All right, so now we'll come down here and we'll take a look at the last couple of problems. It says a company's cost can be modeled by this equation, so C of x equals this stuff right here, where x is the number of units produced and C of x is the cost. So this is going to be a dollar amount, and this is going to be the number of products that they make, it looks like. It says make a rough sketch and label the axes and important features. So I'm going to come over here and I'm just going to draw a sketch, something like this. They've told us what x and y represent. So this is going to be x and this is going to be units. So I'm going to put units right here. And this is going to be C of x, and this is going to be cost. So I'm going to put a dollar sign right there. Okay, so this is the company's cost. This is how much it costs to make this. All right, so it says make a rough sketch. So let's think about what this looks like. This is a parabola, and this parabola opens up. But let's find some important features about this. It opens up. One of the most important features we can find on a parabola is where's the vertex. So let's go ahead and find the vertex. So this is going to be the opposite of b. So that's going to be 120 divided by 2 times a. So that's 2 times 2. So that's 120 divided by 4. So that's, whoops, sorry about that. 120 divided by 4. So that's going to end up being 30. So the vertex is at 30 comma something, and then we're going to plug this in here in order to figure out what that is. So that's going to be, let's see, we'd have 2 times 30 squared minus 120 times 30 plus 3,000. Okay, so I'm going to grab a calculator for this one, make this just a tad smaller so we can see what's going on. So we'll type this in here. So, and again, I'm using a graphing calculator, but I could just as easily use a regular calculator. So this is going to be 2 parentheses 30, close the parentheses. We're going to square that. And then this is a minus. I should make it look like that. Okay, so this is a minus, so we're going to subtract 120 and we're going to multiply it by 30. Using parentheses here, I suppose I don't have to. And then we're going to add 3,000, so plus 3,000. Nothing special about what we're doing here. We've got 30 comma 1200. So let's see what this means. If we were to graph this, this is going to be 30 and this is going to be 1200, and it's going to have a vertex right here. And it says find the minimum cost. So remember, cost is the y-axis. The minimum cost is going to be $1,200. Yeah, $1,200. Okay. Because remember, this is X and this is C of X. So this tells us how many units and this tells us what the cost is. And it says how many units need to be produced. Well, that's the X coordinate here. So they just kind of asked us, like, what are the coordinates of the vertex? They just asked us in the opposite order. Okay, so there's what we've got. Minimum cost is $1,200 and 30 units is what they need to produce in order to minimize the cost. And there's a decent sketch of what that looks like. Okay, now we're going to take a look at this last one. On this last one, it says a cliff diver's motion can be described by that function right there, where h is height and t is seconds. Okay, so let's take a look right here. This is h and this is t. So t is taking a place of the x in this case. So this is going to be the t-axis, and let's write down seconds right here because we do have to make a rough sketch. And h is going to represent the height, and that's going to be in feet. Okay, so I'll just write height. Okay, pretend I can spell. Okay, it says, what is the highest point that's reached? And we need to draw a sketch of this. So let's figure out what's going on here. I'm going to make this just a tad smaller so we can fit it all on there. We're going to take the opposite of this. So that's going to be -4 divided by 2 times -16. So 2 times -16, this is going to be -4 over -32. And that ends up being 1/8. Okay. Now, because this is a story problem, I can choose the best way to write this. It doesn't make any difference whether I say 1/8 or I say 0.125. The important part to think about here is, what is this representing? This is an x coordinate of the vertex. Or we're not using x coordinates anymore. We're using the x coordinate, or the x axis is like t. So this is in seconds. Okay. So this is how long it took to get to the maximum height. And notice that this is a negative. So when the cliff diver jumps off, he jumps off and it goes like this. Okay. And let's pretend that's a parabola right there. So we know how long it took to reach that maximum height. So we may need that somewhere, but it says, what is the highest point reached? So what I'm going to do is I'm going to grab a calculator and we're going to plug that in. So I'm going to do -16, and then I'm going to do 0.125 because that's 1/8, and I'm going to square that. And then I'm going to add 4 times 0.125, okay? And then I'm going to add 51. And I get 51.25. So that means the highest point that it reaches is going to be 51.25, and that would be in feet, okay? So we're talking about how high it is. How long did it take her to reach the maximum height? Well, that's this answer right here. Should have just put it over here. So this is 0.125 seconds, okay? And how high was the cliff? Okay, that is a different question. We've talked about this right here. This is basically the coordinates of the vertex. The vertex is at 0.125, comma 51.25. So let's see. How high was the cliff? Wait just a second. The cliff would be when they jumped. So if you've been in one of my classes, you've heard me talk about these in the sense that this is kind of like a stopwatch problem. When they're counting how many seconds, they click a stopwatch once this starts. So they click a stopwatch right when they jump, and an eighth of a second later, like just barely over a tenth of a second later, they reach their maximum height. So how would we figure out how high the cliff was? Well, they'd just be standing there before the stopwatch clicked. So what we're asking here is, what is h of 0? So if we plug in a 0, so this is -16, 0 squared plus 4 times 0, because that's what we're plugging in for the time. We don't want any time to go by, and we get plus 51. So 0 from this, 0 from this. So the answer on this one is 51 feet. And that makes a little bit more sense, because if you're on a cliff, The max, they only jumped up a quarter of a foot. That's like 3 inches. Because you wouldn't, I mean, you're already on a cliff. You don't need to go any higher. Okay. So there's our answer to this one right here. So the cliff is 51 feet high. They reach the maximum height in their little dive here of 51 1/4 feet. And that happens about an eighth of a second after they jump off the cliff. So we've got our sketch, we've got the highest point, we've got how long it took, and we've got that the cliff was 51 feet high. All right. Good luck on the test.